you look at the timeline and stuff, it says section 1.7, section 1.8. Is that like, are we going to see that today?
Yes.
Okay.
Totally. Yeah. So the first day we basically did sort of 1.1 through 1.6. We sort of did a little bit of stuff from there. I'm going to go back and cover some stuff that's kind of glossed over. That chapter 1, guys. The chapter 1 for the most part is should be treated as review. It should be stuff you come in having seen before, and you should be able to get it quickly if you haven't seen it in a long time. If you have any trouble with chapter 1, I really need you to come see me in my office, and I can try to catch you up to speed, or go see some tutors, or both. Right? Today we're going to kind of focus on filling in some of the gaps from the first 6 sections of chapter 1. We'll do 1.7, 1.8. Those two are sort of things that are a little more involved, right, than just 7 minus 11, stuff like that. They get a little more involved. And we might even get a little bit of 2, probably not, but we'll see. Around 9, a little before 9:30, we're going to head out for a tour of the campus, and it'll end up, I'll end up going to my office, so if you need to see me, I'll be in my office right after the tour, okay? So any other questions from homework or anything? Okay, cool. All right, yeah?
Can we just, I have it all set, we just hand it to you now, or do you want to do it in class?
Any class is fine. Yeah, so you can always turn in homework. Early is awesome. Late sucks. Early is awesome. First little thing I want to ask, it's funny to me how a lot of the things that we talk about in this class are exactly the things that people, even in math 176, math 180, they still kind of have trouble with, right? So I want to get it down now. One thing I've noticed is rounding is a problem sometimes. How do you round numbers? So, for example, if I said round to the nearest, actually let me do it like this. Round this number to the nearest 1,000, 100, tens. This one particularly is kind of a little bit weird. Anytime you have a 9 in there, it might possibly get a little weird. This might be old news to some of you guys, which is awesome. Just hang out, chill. How about this first thing? Round this to the nearest 1,000. How do you round a number? What do you look at? So where's the thousands placed first off? What number's in the thousands? Yeah, 7. So then you look to what number? The 4. If that number, whatever's here, if that number is between what and what, you'll leave this guy alone. 0 and 4. Because then it's closer to 7,000 than it is to 8,000. So really rounding is just saying, are you closer to this whole number relative to this position, or are you closer to the next one up? So since it's a 4, this whole thing I can represent it as 7,000, just round it. Cool. So if I round it to the nearest 1,000, that's 7,000. If I would have made it 7,596, that's closer to 8,000. I would have rounded it to 8,000. Sweet. How are we doing so far? Because we will talk a little bit about estimation, and with estimation, you round to estimate. Right? If I had 7,496 times 11.3, yuck, I could round it to 7,000 times 10, and that would be kind of low. And then multiply that. That'd be one way to estimate that ugly multiplication. What about to the nearest hundreds? So now I'm here, and I'm looking at this number here. Yeah, so obviously 496 is closer to 500, so the whole thing would be 7,500. How are we doing? Everybody with me? Okay, cool. So again, this class is interesting because all you guys have very different backgrounds. Don't freak out right now if you're totally fine with it. That's awesome. Just hang out. And slow me down if I'm going too fast on anything. Now here's where it gets a little weird possibly. Rounding to the nearest tens. There. So now I'm looking at the, I'm trying to get this position here. There's the tens, and I'm looking at the 6.
Wouldn't it be 7,500 again?
Yeah.
Exactly. Cool. Because whenever you have a 9, it gets a little weird because it could either stay a 9 or it has to go up. Well, the next thing up from 90 is 100. So that always freaks people out, though. So actually, the answer for nearest tens is also 7,500. Because 0 is a valid number to have in the 10 spot. So either it stays 9 or it goes up to the 0. How are we doing? Is that semi-decent? Are you guys cool with that? I could even take this idea, we're not to the point where we're going to truly work with decimals all the way out, or see if you can handle a decimal rounding. Given try that one out, see what you get. Again, I don't want you to ever feel steamrolled in this class. Don't let me gloss things over and just keep going. You stop me the minute you're having trouble with any concept. If somebody near you goes, well then let them do that. That's their problem. Let them be bored for a while, they can handle it. There's a little conversation. You have to do them in math class. Yeah, forgot to turn my slide down. Shit, he's talking about it right now. All right, so what do we got here? What are hundreds? What's in the hundreds place first off? 200. And it could either stay at 200 or go up to 300. And obviously, since the 9 is here, it's got to go up to 8,300. How we doing? Cool. Can you understand why, I don't even know if I want to bring this up, but when I tutor science students, and one thing we always talk about is estimation, because in science you're going to be dealing with these big ass numbers or very tiny numbers, right? You're dealing with distances between stars or distances between protons in an atom or something freaky. For some reason I always get somebody tell me that. Can you see why somebody might tell me that? They focus totally on making the 2 a 3, and they forget that this is 8291.76 is not close to 83. But they focus so much on making that a 3, they forget it's got to still be essentially the same number, right? It's 8,000 something. It better still be 8,000 something. So it still has to be 8,300. You just make everything else zeros.
If that was money, that'd be a big difference. $8,300 or $83.
A little bit. How much did you give me $83? Wait, what the hell? Oh, I estimated, dude. So this is a banquet duty. What about the tens?
It'd still be 8,300.
Yeah, so the
Careful now, what's in the tens place?
781.
Oh, not the tenths.
Tenths.
Tenths is coming up on C.
Okay.
What about the tens place?
Tens is the
The
hundred.
9.
The 9, yeah.
I like it.
100.
What number do you look at then?
The one.
The 1.
Oh.
So does this stay in 9 or does this go up to 0 the next?
Stays at 9.
Cool, I like it. So don't over do things with 9s, right? That's not the 9 that gives us trouble because the next number is a 1. It stays a 9, no big deal. So this would be 8290. Coolness. And if you really wanted to, you could put the 0.00. You could put as many freaking zeros as you want to after decimal. It won't change anything. But there's no need for it, really. Now, here's where it gets interesting. What's in the tenths place?
7.
The 7. I love it because it's tenths, hundredths, thousandths. I sound like you have a lisp. And again, you look at the next number. The next number is 6. So that means that 7 has got to
Go to 8.
go to 8. So 8291.8. I love it. Sweet. So that's not really the idea with decimals that gives us trouble because it's the same idea. I don't care if I put a decimal in there. I still just look at the next number and see what to do with this number. I like it. How are we doing with that? Okay, cool. So that was one little thing left over from section 1.4. What about something like this? This is sort of, we're not quite there yet, but we're getting close to order of operations. What about something like this here? If I had 4 times 3 plus 7, like that.
Yeah.
Yeah, so this is kind of like a little baby step towards order operations. This is 4 times what? I don't know yet.
10.
So that's why you definitely wouldn't make this 12 plus 7. That doesn't make any sense. If you really wanted to, you could distribute the 4, but there's no reason to, right? Just do order operations. This is the very first thing in the order operations. Who knows?
The
Parentheses. Because what's the saying? Please excuse
My dear Aunt
my
Sarah.
dumbass son. I mean, dear Aunt Sal. Whichever way sticks in the head. So in here, what do you get?
10.
10. And then 4 times 10?
40.
Cool. I love it. All right, it's not a major deal there. What about this here? All right, it's got a couple things going on. Same kind of idea.
3 times
Negative
I
30.
gotta be careful. So you definitely have to do this first, right? 6 times something. I don't know what yet, so I better figure out what the hell it is. 6 times negative 3. So remember, this is whatever way you want to look at it. I got $2. I owe somebody $5. Overall, I am $3 in the hole. Or they are different signs. The 2 and the 5 are different signs. So 5 minus 2 is 3. You put the sign of the bigger one back on. Right? That's how you do it when they're different signs. It's kind of a nice, quick way to do that. 6 times negative 3 is negative 18. I love it. So if I owe $3 to each of 6 different people, I owe $18 altogether, right? Well, teacher salary take me a while to pay back, especially nowadays. All right, so let's get full into order operations. We got to first talk about exponents a little bit. We did a little bit of exponents last time. Remember that 3 cubed problem? I think I went over a little bit about where exponents were first invented. Some poor fool somewhere had 4 times 4 times 4 times 4 times 4 times 4 times 4. And he had to write that in a paper over and over again. He's like, good God, what the hell? I don't want to write this over and over again. So what he did was he said, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these bad boys multiplying. There should be a way to consolidate this mess. Why do I have to write 4 10 times? There should be a way to say I've got 10 4s multiplying. This won't work. This means 10 4s, but what would those 4s be doing here?
5.
Careful. It is 10 times 4, but how could you rewrite this? 10 4s doing what? Adding. And now the idea of multiplication means repeated adding. You with me? 2 plus 2 plus 2 is 6. 3 2s is 6. Right? So when I write a coefficient, that's a way to make writing this big old addition problem out quicker. So somebody already did this, so this guy's like, damn, he already stole my idea. person.
So wouldn't that point means times? The point?
Yeah, the little dot in the middle, you guys cool with that? That's the times. I'm doing that now because when we start getting into variables, you're going to be like, is that x mean multiplication or a variable? So for us, we're never going to use the x anymore for multiplication. We're going to use that dot. So there's no question, is it a variable or a multiplication sign? Cool, how we doing? So the way that we write this then, he just said, I got to put a 10 somewhere. Just like this guy put a 10 there so he didn't have to write 10 fours out. That sucks. I got to put a 10 somewhere else and then just tell everybody what it means. So he decided, he's like, I may have to put it in here. That's weird. But I don't know, just put it there. That looks good. I mean, if you think about it, this is what I really want you guys to understand. There's ideas, and this is how we represent them. So all of mathematics is a bunch of old guys got together, because back in the day, they didn't listen to women. Finally, women came in. But back in the day, it was a bunch of old guys got together, and they said, how do we write this really concisely? And then everybody else had to agree. So you guys, when you're born and you come into it, you got to go, I got to learn all this crap that they decided on way back when, just so I can do this kind of stuff in the world, right? So they could have done this a lot of different ways. But that's the way they decided, so that's why it means what it does. Cool. Okay. So how do I rewrite, well, there's two of you guys. Rewrite using exponents. Something like this. Let me give you something just a little more interesting here. How do I rewrite that using exponents?
2 times the third power, and then 5 by the fourth power.
I love it. So you say how many 2's you got? 3, and they're multiplying, so it's got to be a power, not a coefficient. So I got 2's. How many 2's? I got 3 2's times 4 5's. I love it. You with me? So let me say something a little bit weird that's going to hopefully help us out later. There is no number 4 here. Some of you guys are like, dude. But there is no number 4. Do you know what I mean when I say that? There's no number 4 here. What does that 4 mean? There are 4 5's. There is no 4 here. There is no spin. What's that?
4 letters.
4, yeah, exactly. Same idea. So there's 4 of those things. So that's why properties of powers are weird. We're not there yet, but you guys remember sometimes you add powers and sometimes you multiply powers and all that. And they're kind of like not what's jives. These aren't numbers. They're just how many of these you've got. They're not going to act the same as numbers. So when we get there, I'm going to say that same thing again. Okay. How we doing so far? Decent? Okay. Here, you guys try this one. Let me throw a little curveball at you. See what you think. So this is obviously a variable. Don't freak out. It's just a symbol. 7 is a symbol. X is a symbol. They act the same way. It's the same idea. Rewrite using exponents. Okay, what you got?
7 to the 5th power times x to the 4th power.
7 to the what now, sorry?
5th power.
Good, so you got 1, 2, 3, 4, 5, 7. So I got 5 7s times
x to the 4th power.
I love it. 4 x's. Sweet. You guys see that? All right. And that, of course, is a hell of a lot better to write than it is to write this whole thing. Now, to be honest, this I could just write like this. Since that's just a variable, I could write it without the dot in the middle. Either way is fine, though. Okay. Yes, sir.
On our homework on page 71 where it has those, you don't want us to stop there, right? You want us to go ahead and multiply that out.
I think on that part, because I still haven't got my book back, which I really appreciate. Can I see yours? Thank you. Which page?
71.
Well, if you would have said no. Oh, okay. Which problem?
Well, just any, because I mean that's what it's showing.
Oh,
there.
yeah. I'm talking about like objective A, and that's homework. Number 1 through 14. Number 1 through 14 is like this.
Yeah, right.
And then number 15 through 44 is further. You with me?
Oh, okay.
Yeah.
So 1 through 14, we stop at that point?
Exactly. Cool.
You don't want us to go?
No, no. It's the next part that I want you to go.
Okay.
In fact, I think they have, there we go. Examples, yeah. Whoa.
We're supposed to get that little blue book back.
Yes.
Is that homework or is that?
What's that?
Is it homework or is it?
Oh, it's stuff that makes it easier for me to do stuff in class. Yeah. So if I wanted to go a little further with the exponents. So now let's say something like evaluate. How would you actually evaluate that? How would you actually do what it says to do?
Write it out.
Yeah, you could write it out. So 2 to the 5th is, and then you just work it out, right? So 2 times 2 is 4 times 2 times 2 times 2, 32. I like it, right? Sweet. So again, just to remind you guys, a quiz or a test will very often have a first part that you'll turn in, and then you get the second part, and the first part will be absolutely no calculators allowed. So you'll have to be able to do things like this without a calculator. How about this here? This one's a little more involved. I like it. So what's 4 cubed mean?
4 times 4 times 4.
Yeah, 4, 4, 4 times 2 times 2. I love it.
64 times 4.
Good. 4 times 4 is 16. Times another 4 is 64. Times another 4. Cool.
96.
A little bit higher. So then you can do 64 times 4. 4 times 4 is 16. 4 and 6, 24 plus 1.
25.
Good. So 256. I like it. And just remind you, obviously in homework you can check yourself with the calculator, but you want to prepare yourself for a quiz or a test. Make sure you can do multiplication by hand. Okay. All right, sweet, sweet, sweet. What's that? Oh, division, yeah. Division's always uglier. Oh, one little thing before I forget, I'm glad you said that. What's 0 divided by anything? So let me just put an 8 there. 0. So what this means physically is I have nothing, and I have 8 people that want something from me, so I'm going to give each of them nothing.
Nothing.
Now, what if I turn that thing around? What happens then?
8.
8 divided by 1 is 8.
Zero. So 0.
Can't be 0. Now here's the weirdness about this thing. If you try to think of it physically, I've got 8 apples. I've got 8 apples. Nobody, not even me, is there. Okay, that's freaky as hell already, right? But let me build you up to this. All right, so hold off on this for a second. So you guys know what? Does anybody know what do teachers normally say here? What do you call 8 divided by 0? It's not a number.
Undefined.
Undefined. So let's figure out why. What is 6 divided by 2? 3. Why is 6 divided by 2 3? Because 2 times 3 is 6. You guys with me? So whatever number I put here, whatever number I put there, what's got to be true? Since 2 times 3 is 6, that's why that's true. Whatever number they put there, 0 times that number must be
8.
How do you do that? Is there any number defined to do that? 0 times anything is 0. Cool. No, you're good. I like, that's the whole idea of being creative. Think about what it could possibly be, but it's just because that 0 down there times anything is 0, not anything else. So this is definitely freaky as hell. I agree with you. Right? 8 divided by 0 is what's officially called undefined. Later you might even know that it's infinite. Yeah. Anybody got the calculator out? Or a calculator? Anybody?
Here.
You don't need it for the first thing they ask you. No, go for it. Thankfully, if I needed a calculator, I'd be. I don't think you'd want me to teach it. 8 divided by 1 is 8. Now, to figure out 8 divided by 0, I'm going to make the bottom get smaller and smaller and smaller. And you guys help me out. Tell me what the division is. You with me? You got? Does that kind of make sense? I don't know what 8 divided by 0 is, so let me do this. Let me do 8 divided by things that are smaller and smaller and smaller. So I'm like approaching 0. Are you with me? So I can figure out what the hell it is. What's 8 divided by 0.1? Now I've gotten a lot closer to 0 here, right? What's 8 divided by 0.1? 80. When you divide something by something really small, you get something really big. What's 8 divided by 0.01?
800.
800. Do you see the pattern now? So what's 8 divided by 0.001 without even using a calculator? 8,000. So it looks like as I'm approaching, as I'm getting smaller and smaller, what's happening to my numbers? Getting freaking big. So when I get as small as I can, this will get as big as I can. That's why it's also called infinite. Because that would be infinity, right? It's the biggest thing possible. And actually it's a process, not even a number. But you guys semi with me? So I love to explain that because very often teachers will say it's undefined, but they won't explain why the hell do you call it that? Why don't you just call it weird as all hell? The reason we call it undefined is there's no number defined to do what it's supposed to do there, so it's undefined. Bam, that's it.
So if we come across that problem, we can write undefined.
Yeah, anything divided by 0 is undefined. So that's exactly what you can write. If anybody's teacher taught them infinite, that's cool too. But normally it's undefined is what we consider.
I was just thinking.
So no matter what is divided by 0 is always undefined.
Exactly. Even 0 divided by 0. To be honest, that's the worst. Because 0 divided by anything is 0. But anything divided by 0 is infinite or undefined. And so what the hell? That's even worse than undefined. That's what's called indeterminate. We don't care about that. All you got to worry about is if you said undefined, I'd be cool with it because this thing is super freaky. Right. Basically, anytime you try to divide by 0, things freak the hell out. Cool. Okay.
So why would they bring that up in their equation?
Because sometimes an equation, what happens in real life? You have a problem, you're trying to figure out how to solve it. In real life, some problems don't have a solution with it. So thank God math, if you want to believe in math at all, it better have problems that don't have solutions. Because that's what life is like, right? So math is this big thing about how to explain life. It is a little bit. It better have situations that mimic what we see in real life. So I could have an equation where the answer ends up making my bottom 0, so there's no answer.
But why wouldn't you go into that number then? Go into the number that you trying to get something out of nothing.
Oh, I got you. Well, it's just because that just happens sometimes.
Yeah.
And what this is, when I see this, the math is trying to tell me there is no solution. There's just no way to do
Just
it.
leave it alone.
When I got an equation and I get something like that, it's saying there ain't nothing you can do. There's no solution. Too bad. Yeah. I'm not trying to be pessimistic.
No.
I'm just trying to be realistic.
Right,
Yes.
right, exactly.
Okay, so let's get fully into order of operations. And don't worry, if I'm not going to be talking this whole time. I got another little handout, I think, like I said earlier. that I have you guys work on, so you don't just have to listen to me the whole time.
I went over there, I thought we was meeting over the library and everything. I went asking, Yvonne and all the.
Oh, you know we're meeting over there? No. No. All right, so again, you guys told me the order of operations, please excuse my, dear Aunt Sally is fine. Now, I wrote it like that, and that's the last time you'll ever see me write it like that, because students get really confused about this and this. They could have called it this. They could have called it that. Which one's easier to say? PEMDAS. How do you say this? PEMDAS. So the point I'm trying to make is you don't do multiplication before division necessarily. You do them as they come.
They side by side, right?
They are, but here's how I write this. And of course, all your math teachers always have the little quirks. But to me, this just makes more sense. If you write it in a line, it looks like first, second, third, fourth, fifth, sixth. And that's wrong. That's the mistake that people make when they write it like this. It's actually like this. First, second, whichever one's first you do, whichever one's first there you do. So you definitely do adding, subtracting last. But you don't do addition before subtraction. You just do whichever one's first. So let me give you a really good real-life example of how messing this up would screw you over. Let's say you have $5 and you owe somebody $11, right? So that's bad. But then you walk along the street and you find a $20 bill. Well, then you should be good, right? You should be able to pay him off and still afford some lunch. But if you do addition first, you might make a mistake. You might think it's 5 minus 31. Do you guys see that? And that's somebody who's following this exactly would do that because A comes before S. But you see how it doesn't jive with real life. And the major mistake we made, is that 11 positive? No, it's like a minus, isn't it? But somehow we put 11 with 20 when it should be a negative 11 and 20. If you did that, you'd actually be fine. So this is obviously wrong. This will put me $26 in the hole. Right? I don't want you doing my checkbook. So what's the right way to do it? You do it as it comes. So that's what this says. This says if you're on this level, I don't have any parentheses, exponents, multiplication, division, so I'm only on the AS level. You do it as it comes. So 5 minus 11, yeah, negative 6, plus 20. Remember, when they're different signs, you subtract them. 20 minus 6 is 14, and you put the sign of the bigger one on positive. And that jives your real life. I owe you $11, I got $5, but I find a $20 bill. I should have some money left over, not be 26 bucks in the hole. Doesn't make any sense. How we doing? Now here's something I'll admit is sort of a trick question. I would never put something like this on a quiz or a test. But let me see if you guys can get this. It's one of the most evil little problems I've ever come up with. And I don't do it on purpose to mess you up. I do it to show you the mistake that can be made. You guys all cool with what operation does this mean? Multiply. Now, when I say P, when I say parentheses, that doesn't mean wherever you see parentheses, you do that first. That means whatever's inside the parentheses. So is there anything to do inside here? It's just a 4. Is there anything to do? No. So this is just multiplication. So who thinks they know the answer to this?
0.
What is the answer?
1.
And it's not 1.
0.
0.
I told you it was a trick question. It's not. It's definitely not 0. Yes, ma'am.
4 times 4.
16. So, what do you do when you're? So I'm only on this level here, right? I'm on the multiplication division level. I don't do M and then D. I do it as it comes. What's 4 times 4?
16.
16. 16 divided by 4? 4. 4 times 4? 16. Okay. Our brains, of course, see this as breaking it up into two things. So we do 16 and 16, then we divide it? You guys, so far so good? Okay, so watch one little thing. Let me see if you guys get this. If I thought I was supposed to divide, what am I dividing by? Am I dividing by 4, right? I'm not dividing by 16.
Right. One person.
So if I rewrote this, it'd be 4 times 4 divided by 4 times 4. If you did the 4 times 4 first, you put that 4 somehow down there. How did you do that? You see what I'm saying? Good, good, good. These are the things that really frustrate the hell out of people. I totally understand. That is definitely a bit of a trick question because our brain kind of gravitates towards those two things.
Yeah, only because of the order of operation is not up here. You ain't sitting it up here first.
Exactly.
You know?
That's right.
Yeah. That'll throw you off.
Okay.
It'll throw me off.
Oh, hell yeah. It throws a lot of people off. So tell you what, let's do this.
So for that example you have down there, what do you do first?
Well, which one?
That one there, the one you rewrote at the bottom.
Oh, this would come out the same way. This is the same problem, just rewritten. Because isn't it 4 times 4 divided by 4 times 4?
Yeah.
So what would you do here? 4 times 4?
16.
16. Some of you guys might realize what happens with those 4s. They cancel. But let's just go straight. 16 divided by 4? 4 times 4? Of course it's the same because these are the same problem.
Right, but if you did the division before the multiplication.
If you do the division before the multiplication, if you like cancel these out, yeah, that'd be fine too.
That's fine as well.
Yeah, because if you cancel those out, 4 times 4 is still 16.
Okay.
Yeah, cool. Okay. So let's do this. This is kind of a review of everything we just talked about. How many of you guys have the book already, the little blue book already? Okay, I think I have enough copies. So I want you to get in the groups again. But let me do this real quick before you do that. When you come to your row, raise your hand if you want a copy of this.
Well, teacher, I don't understand what you say. Number 2.
Say again, sir.
4 by 4, 16. And divide 4 by 4, 16. Well, the result 1.
All right, let me do it again.
I don't know.
You do not multiply before you divide. If the only thing you have to do is multiplication and division, you do it as it comes. So let me show you this. 8 divided by 4 times 2. What am I dividing 8 by? I'm dividing 8 by 4. I'm not dividing 8 by 8. You with me? So, order operations, the way that people write it normally, makes it look like M comes before D, but they just had to pick a way. They can't do both. They can't have some weird MD letter that's kind of changing all the time. It's a little weird. They have to put something. That's why I don't like to write it like that. I like to write it like this. So when you're on that level, you do it as it comes.
I've never seen it like
So
that.
8 divided by 4 is 2, and what do you still have to do?
2.
Times 2 is 4. It's not 8 divided by 8 is 1. You with me? The same thing here. It's not 16 divided by 16.
We do the first and the second and third.
You do it as it comes. When it's on the same level,
Yeah.
when it's on the same level, you do it as it comes. That's the hardest thing to get down about order operation.
I think that's the best way to do it, because I ain't never seen it like that. They
Whatever.
ain't- Nobody ain't never
Whatever
done
helps.
it.
Who needs a copy here? For those of you who have the book, it's page 17. Sorry. So do it this row. Do it again. Sorry. Raise your hands. Okay. One more. Here, who needs the copy? I think I got it. Think. Let's see. Who needs a copy here? Okay. Oh, here, who needs a copy? Oh, you. No, this is just for you guys to practice. Oh, wait. Oh, it's in the little blue book. Oh, yeah. Oh, okay. There. And you need one?
Did you ever take a roll? I don't remember you doing that.
I won't.
Okay.
This is college, you pay for it. I will, what I use for roll is when I give quizzes. So that's why I told you, I can drop you if you're absent 3 times in a row. But I don't like to waste time to roll, so. I got you. Okay. I know, but then it's really easy for somebody to sign. So it doesn't matter. Bring it in on Tuesday. Yeah, cool. That's the day we'll talk about it. No, that's gonna be like in class stuff to do. Yeah. Oh, you could do groups of 2, 3, or 4. Maybe not groups of 20. Yeah. 2, 3, or 4.
Yeah, that's right.
Oh yeah. Not necessarily staple.
That'd be easier.
That's the so they'll see the text. You don't have to have that's recommended, but you definitely need the text.
3, 4.
Oh, you already did that. Well, tell somebody else.
16 times 4.
Or you can go ahead and get it. Get it. No, that's yours to use. Use that. It's up to them.
You don't want us to solve for the first 2, right?
Yeah, I think it just says rewrite. Yep. So you don't have to get a number.
Evaluate.
Go all the way through.
Get down to a number, yeah.
You could go 91. That's 90. Evaluate 91.
Yeah, get that down to like a no exponents, just a single number. But which one do you do first? That's the important thing. No, that's number 10. The problem is here, so that means and that's so which one's an operation? Exactly. It's PEMDAS, PEMDAS, so multiplication before subtraction. So you rewrite everything the same way except you replace the successful. Oh, that's just saying number 10. That's the So like you have one
It's only 3 4 or 3 4s.
well, the thing here is if you multiply 1 times 1, you get 1. So it's not adding, it's multiplying. So one of these 1 to any power will end up being just 1 times itself, it's 1 times itself, it's 1 times itself, it's 1 times itself. 1 to the billionth power. Yeah, 10 times 10 is
32 minus 6 is 26. You have to do that first, and then you would do 20.
add another 0. Every time you multiply by 10, you add
No,
a 0.
I was going to try to 10
10 times 10 is 100. Times 10 again is 1,000. Yeah, they have 10 as well.
What do you want to do?
You're right, I think this one's. Yeah. That's all. Yeah, well, so you're supposed to do this one before this one, but then here I did this one, right? Yeah. So that's the only one I'm not sure.
So what do you do for subtract? You gotta do your operations. So this will be 32 minus, I don't know yet. So you gotta figure out what 6 times 4 is.
Oh, yeah, I'm sorry, I'm looking at A, I'm like, it's about 10. Sorry. No, you're
That
fine.
everybody agrees on so that we always keep the same. Yeah.
That's what I always did wrong. Like,
That's
and I didn't
I
know.
remember when I used to do this, I had like a hard time getting it down, but now that we're doing it again.
Yeah, 10 is fine except for so this looks good right there, except it'll be 8.
and then 3 to the 3 power. So,
But here, I'm not sure what's going on out there. Gotcha. So here we have subtraction and multiplication. Multiplication first, that's perfect.
I don't remember all that counting now. So I'm just gonna try and do it with.
Here's another way to do it. 24 is 608 and 30. Then you have to alternate.
nine times 3.
This is where I always get stuck. Over. Like, I know I did square root first, then do the multiplication.
And the cool thing about when you have a big bar like this is you do the top all the way out, do the bottom all the way out, and the last thing you do is you do the division.
Okay, that's where I get lost.
Wow.
So it's 5 times.
Oh, yeah. Exactly. So you do the top all the way out, the bottom you do there, the bottom all the way out, the last thing you do is
See, that's where I always would get lost, because then right after the top, you're done with the multiplication, then you're like, okay, well, you have to see division, so
That's
you
why
start dividing shit.
it's a long, but for me, I just keep writing it out, writing it out, writing it out. Because I know there's steps to skip, but I.
See, I became number 15, but then I started solving it here at the beginning.
1 and 2.